Here we have a pre-calculus problem. Okay, let's go with the question. If p to the xth power equals to q, q to the yth power equals to r, and r to the zth power equals to p to the sixth power, then the value of x times y times z will be. Okay, let me take the first equation as it is. That is p to the xth power equals to q. Okay, now let me write the next two equations. That is q to the yth power equals to r, and r to the zth power equals to p to the sixth power. Okay, now what I'm going to do is I'm going to solve for q in the second equation. So once I get the value for q, I can plug in for q into the first equation. Okay, to solve for q in the second equation, I have to get rid of this exponent y. So to get rid of the exponent y, I have to raise both sides of this equation to the power of 1 over y. Okay, let me do it. So q to the yth power is raised to the power of 1 over y. On the right side also, I am raising this to the power of 1 over y. Then I'll be getting r to the power 1 over y. Okay, here we have exponent y for the base q, and for this complete stuff we have the exponent 1 over y. Okay, whenever we have two exponents like this, we can multiply the two exponents using the power of a power rule in exponents. Then I'll be getting q to the power y times 1 over y. I just multiply the two exponents over here. Then I'll be getting r to the power 1 over y. So now I'm getting, so y will cancel out here. I'm just getting q to the first power. Q to the first power is just q. Q is equal to r to the power 1 over y. Okay, now so what I can do is I can plug in. So now I got the stuff which is equal to q, that is r to the power 1 over y, that is equal to q. So now I can plug in that is r to the power 1 over y for q into the first equation. Okay, let me do it. So p to the x power equals to, instead of q we can write r to the power 1 over y. Okay, now here on the right side of this equation we have r, so we have to solve for r in the third equation. Okay, now let's solve for r in this third equation. So to solve for r, I have to get rid of the exponent z. For that I have to raise both sides to the power of 1 over z. Okay, now let me raise both sides to the power of 1 over z. Then I get r to the power z to the power 1 over z equals to p to the sixth power to the power 1 over z. Okay, here we have to multiply these two exponents using the power of a power rule in exponent, that is z times 1 over z equals to the same thing. We can multiply these two exponents, that is 6 times 1 over z. The z will cancel out, and I'm getting r to the first power, it's just r, and p to the power 6 times 1 over z is this 6, and the numerator 1 can be multiplied, and we'll be getting 6 over z. Okay, now I got the stuff which is equal to r, that is p to the power 6 over z. I can plug in this p to the power 6 over z for r into the first equation over here. Okay, let me do it. So p to the x power equals to, for r we can plug in p to the power 6 over z to the power 1 over y. Okay, so p to the x power equals to, here we can multiply the two exponents, so we get 6 over z times 1 over y. Okay, we get p to the x power equals to p to the power. So whenever I multiply two fractions, I have to multiply the numerators and multiply the denominators. 6 times 1 is just 6, and z times y is zy, or it can also be written as yz. So here the two terms are equal with the same base p. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. Then I'll be getting x equals to 6 over yz. Okay, now I'm going to multiply both sides of the equation by yz. So yz times x equals to 6 over yz times yz. So this yz will cancel out. So the resulting equation will be yz times x can be written as x times y times z. On the right side, we just have 6. Now I got the value of x times y times z, that is equal to 6. So the correct answer choice for this question is option D.